to the mill at Anselma on Route 401 in West Pikeland Township. Our tour guide today will be Earl Reese, who is a volunteer and lives in Hershey's Mill.
Thank you. I'd like to welcome you to the mill at Anselma. This is a National Historic Landmark. The mill was originally built in 1747 by the Lightfoot family. The family operated the mill for like 87 years, and then it was sold. But the original mill was what they call a custom mill, and they just ground grain for the local farmers, and the farmers would leave some grain to pay for their cost of the milling or pay in cash. The mill was then sold to another family which operated the mill for 20 years, and it was sold. So over the period of time, there was 6 major owners of the mill. Now, the mill is what they call a custom mill, which I had mentioned before, and it's powered by the water that you see here from a mill race that runs back through the property to the Pickering Creek. We have a gate back there we open up to let the water flow into the mill race here. It goes through the gate into the large pipe into the mill, which in turn turns the water wheel, and it is an overshoot water wheel, which means that the water flows in the top of the wheel, and we use the weight of the water to generate the power. So when we get through here, we'll go in and look at the water wheel and see how the mill operates.
You're actually grinding grain here and selling flour, right?
Yes.
Okay.
Yeah, we operate the mill the second Saturday of each month, and we have it open for people to visit on Saturday and Sunday of each Saturday and Sunday of each month through December.
Okay. And you can people can go in there and buy flour to make pancakes, to make cakes, and
yes,
that's great.
We also sell stone ground whole wheat bread that a local baker bakes for us. So that is available also.
And that's very unusual. You don't find that many places in this area, I don't think.
No.
Okay. What else can you tell me about who's in charge of this, how you raise money?
Well, the mill is owned by the Anselma Education and Trust Incorporated, and they have a executive director that contacts major companies for donations, and they get grants from the Pew Foundation, PICO, and the Chester County Tourist Bureau.
I believe you told me this was built in 1847.
1747.
Oh, 1747. Yes. Okay.
It was one of the first mills built in West Pikeland Township. At one time, there were 8 mills in West Pikeland Township.
And that would be because this was a big farming area?
Yes.
And that was, grain is what they lived by and sold and fed to their animals, their farm animals. Yes. Also, right?
Plus, the families had wheat ground here to make flour for doing the baking. They also furnished flour to George Washington's Army in Valley Forge during the Revolutionary War.
This particular mill?
Yes.
So a lot of history here.
Very much so, yes.
Well, do we have a miller here?
Yes, we do.
Okay. And
his name is Dave Rolandhagen. He's our miller, and he's been involved here ever since the year 2000 when they started the restoration of the mill.
Is he also a volunteer?
Yes.
Okay. How many volunteers do you have here?
125 active volunteers.
That's a wonderful organization. Well, thank you for this little visit. Now we're going to go inside the mill and see how everything is done. Thank you.
We're very fortunate in this area to use the topography of the ground to have what we call an overshoot water wheel, where the water comes in the top of the wheel and fills up the buckets to help generate the energy to create the horsepower needed to operate the mill. As you can see, the wheel is an inside water wheel, which was built that way because of the harsh winters in the area, because the mill was operated primarily in the winter time. Originally, the mill, when it was built in 1747, had a wooden water wheel, and it was so costly to keep it maintained and so much downtime that in 1905 they replaced it with a steel water wheel. And we've used the steel water wheel to operate the mill ever since. As you see, the wheel, as it turns, it has 48 buckets, and each bucket will hold 5.8 gallons of water. And with the weight of the water is what generates the power to drive the mill through this shaft here into the other side where the power train is connected onto it. We get our water from the Pickering Creek. It flows through the mill race, which you saw earlier. It's discharged through the head box onto the water wheel, and the water is discharged into the tail race, which again runs back into the Pickering Creek. So we're just using the water and discharging it back into the source where it came from. What you see here is the hopper where the grain is fed into the grinding stone. Here in the grist mill, originally there were 3 sets of stones. 2 of them were stones for grinding wheat and flour. This set of stones here is for primarily grinding corn and cattle feed. But since we only have 1 set of stones in operation, we can grind wheat as well as corn. We are certified by the Pennsylvania Department of Agriculture, where we can grind flour and sell it to the public. And also we have a bakery that bakes bread for us out of our stone ground wheat bread. Now the mill is, we're going to start the mill up now. It's made up, the set of stones is made up of 2 stones. One is called a bed stone. The other is called the running stone, which the grain is fed into the center of the stone, and by centrifugal force it's forced to the outside through the grooves that are chipped into the stone. The stone has to be sharpened every couple of times a year so that it is efficient in grinding the grain. As you can see, the grain is being fed down now into the center of the stones, and we can control the fineness of the flour by the distance the stones are apart. This case around the outside contains the flour that is ground, that comes to the outside and down a chute down to the miller's operating stand. This running stone, which you see turning, is a 1 piece of granite that was quarried in Virginia, and it weighs 3,200 pounds. When we finish grinding, we have to take this all apart and clean it. And before we start operating to grind grain flour to sell, we have to sanitize everything. Everybody has to wear gloves, and everything has to be sanitized. So we have a large lift over here which we use to lift the stone off so we can turn it over to clean it and to sharpen it. What you see here now is an addition to the mill. This was added in around 1822. This is a conveyor system that was invented by Oliver Evans, and this was installed to take a lot of the labor out of operating the mill, because before this was installed they had to carry the flour up to the 3rd floor to have it sifted or lifted up by a hoist that was operated by the water mill wheel. This took a lot of the work out of it, and this is where the grain is transferred from one floor to the other. And this station here is where the bagging took place. I'd like to introduce Dave Rolandhagen. He's our miller here at the Anselma Mill. He's been on board here since about year 2000. He knows all about the mill, all the grinding operations, and so on.
Thank you, Earl.
He's a very knowledgeable person, and he takes care of any troubles we have here. I'd like to explain a little bit about the set of stones that you see here. These are called burr stones, and we have 2 sets. One here that's already assembled with the harness on it, and this one is apart so you can see what the stones look like. Now, this is what we call the bed stone, and this is the running stone. And this material in this stones came from France, a quarry outside of Paris. And it came over to this country as ballast on ships. And they would cut the stones and put them together and put steel bands on them and pour plaster Paris around to hold them together. And this structure of this stone is entirely different than the one that you saw before. This is a solid piece of granite quarried in Virginia. So to make this operational, the stones are put together and set on this drive shaft here, which I'll have Dave explain what they're called. He knows a little bit more about that than I do.
Okay.
Dave?
This is the spindle that comes up through the floor. It's a long piece of wrought iron steel, and it comes to a point, as you can see. And this stone has a crown in the middle of it that fits right on top of this spindle, right on the very tippy top there. So when this stone is inverted in its position, it is perfectly balanced on the point of that spindle. This bar here is called the driver, and that driver fits in these 2 slots, and as that driver in the spindle turns, so does the stone. So this is the main driving mechanism that makes this runner stone turn, and it's driven from down below, which you'll see shortly.
Now, as you can see over here, this is how they control the amount of grain that goes down into the stone by this leather strap that's hooked onto a knob at the miller station. And that elevates the shoe that controls the amount of flow of grain that goes down into the eye of the stone. Also, they can control the distance between the 2 stones by what they call the bottle beam. That's at the operator station also. So the operator has complete control of the mill all at one station. Stay tuned to channel 20 for a station break.
This we call the wallower, which drives the counter shaft, and through that face gear drives this gear we call the stone nut. So this is how the machinery operates, and it's fairly basic. Now the miller has 3 controls at his disposal, and they're right in this area here for this set of stones just above. The most important is this bottle beam here, and this controls the spacing between the 2 stones. And by controlling the spacing between the 2 stones, I can control how fine the meal is coming out of this chute. So if I want to make a coarser grind, I pull down, and that raises the top stone, and then what's going to come out here is a much coarser grind. On the other hand, if I want to make the grind finer, I'll lift the bottle beam like this very slowly, and that will drop the top stone, and now what's going to come out of here is a much finer grind. So for cornmeal, we would want a coarser grind. For flour, we would want a much finer grind, so this bottle beam would be much higher in the case of flour. So that's one control the miller has at his disposal. The second control is called this crook peg, and you can see that it tethers a leather strap that goes upstairs to what we call the furniture on top of the stone. And by turning this one way or the other, I'm controlling the angle of the shoe that's just above the runner stone. As I loosen this and turn it counterclockwise, that drops the stone, the angle is greater, and so more corn flows into the stones. On the other hand, if I turn it clockwise, that raises the shoe and less corn falls into the eye of the stone. So this is the second major component that the miller has at his disposal to control what's going on. The third is this lever over on my far right. This lever controls the amount of water flowing over the wheel. And when I lower this lever, it increases the flow of water over the wheel. When I raise this lever, it decreases the water over the wheel. Now the reason that's important, if I can go back over here, is because when I want a finer grind and I raise this bottle beam, that lowers the stone and there's more friction between the stones, so I have to increase the flow of water in order to compensate and keep this turning at the right speed. So all of these three functions are interdependent, and if I can change one, I have to change something else. Now you can see that this meal spout, we call it, goes up at an angle right through this big beam here, right up into the hoop surrounding the two stones. So the meal is being collected in that circular hoop, and as it comes out from between the stones, it gets swept around into this chute, and this is where everything comes out. Now, for cornmeal, this would be pretty much the end of the process. We might sift it once, but generally this is about the consistency we're after. In the case of flour, however, the situation is different. We would then take this, the meal, the flour coming out of the chute, and historically it would go back up to the third floor into a giant bolting machine or sifter, which separates the flour into three grades. A very fine, superfine flour, we call it, a medium grind, and then a coarse flour. And they would be packaged separately because there are three different screens on that sifter. The miller, if he wanted to, could take the coarse flour and he could send it back through the stones and regrind it to make better use of the wheat that's coming in and get a higher yield. In our case, we do the sifting down here using a motorized sifter, but we could equally as well use the sifter on the third floor, but we don't have the volume that would support that. So that's basically the operation of this set of machinery here. The same situation is exactly true for the other two stones. There's a stone nut which drives a spindle in the two other cases. There's a bottle beam in the other cases, a crook peg, and so all of this is duplicated in the other two positions for the other two stones. The only one that's common to everything, of course, is the control of water. And a miller would never run more than one set of stones at a time, so that the water control would control the flow of water just at the specific location or the specific set of stones he's using. The way we turn on and turn off this machinery, if I can use that phrase, is by virtue of these levers. One here and one on the other side. And if I loosen this hand wheel, I can pull out this lever, and that moves the shaft out and disengages it from the master gear. Now, of course, we would never do that with the machinery turning. So what we would do is stop the flow of water, shut this down and then disengage or re-engage the counter shaft depending on which side we're using. So that's how the miller controlled which one of the three sets of stones he was using. Okay, these are the two other sets of stones to my right. There's a set over there, and you can probably see a spindle that goes up through the floor for that set, and then there's a set that I'm standing in front of right here, and that's the spindle that would drive that set of stones in the middle. And as you can see from here, as I mentioned before, this is exactly the same setup. There's the bottle beam, there's the crook peg, and there's the spout where the grain comes out in this center position. The other thing that you can see from this angle, which is you can't see on the other side, is this grain elevator system. This elevator system was put in place, we think, around 1820. It was not originally part of the mill because it hadn't been invented at that point. And these buckets are mounted on a continuous belt inside that elevator. And as the buckets go down, they scoop out the flour from the bottom of this elevator housing and carry it up to the third floor where it dumps the flour into the bolter for sifting. So this was an important addition to the mill because otherwise the miller had to carry the flour up in sacks up and down all day, and this made it much easier to take the flour right out of the chute. There would have been a connecting link down here so that the flour would come out here, go directly into this elevator, go up to the third floor, be sifted, come through the sifter, and be packaged. So this became a fairly automated process with the addition of this elevator system. The other thing to note is this entire machinery setup is supported by what we call the Hurst frame, which consists of this huge beam going across as well as these uprights that support it. There's a similar set of beams on the other side, and this constitutes a rigid structure that supports all of this machinery so that we could take away the building and this would actually operate as a mill without the walls. The reason for that is they deliberately tried to isolate this Hurst frame from the structure itself so that the vibration of the machinery didn't knock the building walls apart because they're stone. So this is a fairly standard self-contained structure consisting of these horizontal beams and the uprights. And this beam going across supports the spindles, in this case right here, and identical situations for the other two sets of stones. This we call the bridge tree. The one other thing you can see here that's not quite as evident as I showed over on the other side is that when I release this bottle beam and go up and down, you can actually see this moving up and down, and you can see a little better how the spacing between the stones is adjusted because you can see the movement in this case. So again, when I pull this up, that raises this bridge tree, pushes the spindle up, and the stone goes higher. So that's a little easier to see in this position.
This miniature water wheel you see here was built in the shop at Hershey's Mill. Myself and Mickey Sugar helped me with it. And the reason for this is to demonstrate to children how the water wheel works. We put water in the bottom of this bin here and pump this pump here, and the water flows out here onto the water wheel, and the water wheel turns. The kids are fascinated by this, and they'll stay and play all day long. And we use this for taking around to schools or demonstrations here at the mill when we have children here as part of our education program for the young people. And we have gotten one of our very important volunteers here at the mill through the demonstration of this water wheel at the food market in the area here because they visited the food market, and the kid became so fascinated with this water wheel that his mother joined here as a volunteer, and she is one of the people that has furnished us with a lot of our recipes for the mill, and she's very instrumental in our baking and so on and so forth. What you see here is the what was called the night miller's house. At one time, the mill here operated 24 hours a day, and the night miller, the person that operated the mill at night, lived in that house there. It was built in about 1875. The white portion of the building to the right was added on approximately 1934, and that housed the post office at Anselma. When they shut the operation of the mill down from an actual grinding operation, they needed an income, so Mr. Collins applied for a job as postmaster in Anselma. So he got the job, and they built that addition on, and that was the post office here in Anselma until 1958. He used that money to help support his family, and it was taken off and put over in the field and put back in where its present location 2 years ago. So over here you'll see the spring house. It's a two-story spring house, which many of the farm properties, mills and so on had on the property for a source of water and also a source of refrigeration to refrigerate the milk and their butter and eggs and things like that, and their fruits. The water temperature in the mill was about 55 degrees, and it was enough to maintain, the items that had to be refrigerated for a few days. This big tree that you see alongside of it here is a sycamore tree, and we estimate that that is about 225 years old. On the spring house there, you see that there's a vent goes up through the top, and it's the only spring house I've ever seen that has a vent like that in it, and that's to vent the moisture out of the spring house area in the lower level. I hope you enjoyed the film that was shot here at the grist mill at Anselma. We have a grinding day here the second Saturday of each month from 10 to 4, and it would be a lot more interesting for you if you came out to see the actual operation of the mill. We have a historic landmark here, and the reason for it is it's one of the most rare mills of its kind in the United States. So please stop out and visit us. We're open every Saturday and Sunday during the summer from 10 to 4.